Hey guys, it's Hannah Albano.
And I'm Edgar Pineda, and this is our presentation of our signal transduction pathways. Signal transduction is the second step of cell signaling process. The transduction stage converts a signal to a form that can bring a specific cellular response. These occur usually in the steps called signal transduction pathways.
Our example we will show is the example of Nobel Peace Prize winner Earl W. Sutherland that helped understand how chemical messengers act during signal transduction pathways. Our model depicts epinephrine, our signal, creating an indicator to make a cellular response, which in this case is breaking down glycogen into glucose. This helps maintain glucose levels whenever you're in a stressful situation. So imagine you're in a situation where you are stressed. Maybe you're about to take a SAT or biotest. Who knows? The hormone that is released is epinephrine from the adrenal gland. Epinephrine is released into the extracellular fluid and it binds to a G protein coupled receptor on the plasma membrane of a liver cell. Once the epinephrine binds to the receptor, the G protein coupled receptor activates another molecule called adenyl cyclase. Adenyl cyclase converts ATP to cyclic or CAMP. Cyclic AMP becomes a secondary messenger that then moves to two enzymes of the liver.
The first enzyme is active glycogen phosphorylase, which is the first pathway I'll be talking about. The CAMP approaches the active glycogen phosphorylase, where phosphorylation occurs. CAMP oxidizes and gives up a phosphate to the enzyme. Phosphorylation from the CAMP stimulates glycogen phosphorylase, converting glycogen into glucose, which is a cellular response in this cell signaling process. Inactive glycogen synthase is the second enzyme that undergoes phosphorylation, which is the second pathway I'll be talking about. Similar to the first pathway, the CAMP approaches the inactive glycogen synthase, where phosphorylation occurs. This enzyme contributes to the synthesis of glycogen, but phosphorylation from the CAMP prevents it from working. This guarantees that when glycogen needs to be broken down, no new molecules are created.
To summarize, signal transduction is the second step in cell signaling, and the example of epinephrine binding to a liver cell's G protein coupled receptor demonstrates how it sets off a chain of reactions. And the reaction starts with the G protein coupled receptor activating the adenyl cyclase. And the adenyl cyclase then converts ATP to CAMP, which acts as the secondary messenger for the cell. And the CAMP then activates the glycogen phosphorylase due to phosphorylation, resulting in the conversion of glycogen into glucose, which proves that epinephrine does not directly interact with the enzymes and there are intermediate steps in between the breakdown of glycogen.